Okay, so that last episode we kind of ran into a roadblock. We spent a lot of time on something, and I don't think it was all that worth it. So, yeah, sum of multiples. I'm not. Let's see, 87% about. I mean, I don't know. I feel like we could do it if we come back to it, but let's find something else. Like, make uppercase. There we go. This sounds promising. Write a function which converts the input string to uppercase. There we go. Alright, so super easy. All we gotta do, so this is the easy one, return s dot upper. Literally, that's all we need to do. And then, yeah. But what else you could do is do for letter in s, and then you could also, if you were building it letter by letter, like to return, so a variable that we're like to return equals empty string, and for every letter in s, to return plus equals letter dot upper. So, and that's just what you do to call another function on something. So, and let's see, return to return. See, we can even do that, and that'll hit first. We could comment it out, but it doesn't matter because like. And it'll still pass all the tests. We can comment this one out. Like, that's the first one we did. And then we can comment this one out and prove that this one does it too. So, super easy. Let's, comment, oh, whoops, Control Z. Let's just do Control X, cut that, put that very first one, and then we can prove that, oh, we know how to do the easy way, but let's do it painstakingly, and let's construct it letter by letter. So, and we could even do like, well, I think that's pretty explicit. So let's test again, make sure that we're passing the basic test. See, 507 milliseconds, so that's 1,000th of a second. So that's what, 500 milliseconds, so half a second. Ooh. Look at all these things, and we passed all of it. And they're trying to throw everything at it. But see, this is kind of cheating because it's like, it's a built-in function. I don't know. Well, not cheating, sorry. It's just a very easy challenge. So if you're aware of this built-in function, now if you're not aware of this function, of course you are to do this. So I don't even know how to make it. You could do like ASCII, like based on the ASCII values, but then you would have to like translate the incoming letter into, but yeah, so that's a nice easy one. Let's go ahead and submit that. Okay, so yeah, a lot of 8s are supposed to be like that, like a little, quick things. Let's go to another. Click out of it to get updated. Get character from ASCII value. Okay, so that's literally get char. Wait. Alright, so Python ASCII to char, and char is character. Basically, like, we write a function which takes a number and returns the corresponding ASCII char for that value. So this is important to know, but char is a built-in function to convert the ASCII code into its corresponding character. Okay, so that's easy, so we just got to do that, and we're building it in a function. So like the little smiley face. Oops. 1, 2. Actually, you know what? What are you doing? Tab. Enter. You can do it. You can do the spaces technically uniform, like 1, 2, 1, 2, but I don't like it. I'd rather just do tab because then you get all that weird pink stuff. And all right, so return see. Was that what it was? Chur. See, that's it. So it makes you go to the internet and look up how to get the, and Python has a built-in character. Now, it is hard in languages like Java because, I mean, there's a lot more potential, and I know that some of the projects we did in college depended on that knowing the ASCII values. So if we were trying to determine if it was upper or if it was lowercase, but we couldn't use a built-in function, we would have to say, is the ASCII value greater than this or lower than this? And this involves pulling up an ASCII table, so ASCII table, and then looking at an image of it. And see, there you go. You click any of these, and boom. That's kind of okay. There you go. It got cleared up. So there's a decimal value, a hexa value, which is hexadecimal, and then the actual character of the char. And these are all the ones. So 42 is an asterisk, the meaning of life, Douglas Adams. I'm just kidding. I don't know if that's what he intended, but it's a funny coinkydink. So the asterisk is a wild card in computer science for everything. So saying 42 is the meaning of life means that the meaning of life is everything. Everything that we know, that we've experienced, that we can experience, that other people are experiencing, it's all the meaning of life. So yeah. Anyways, back to coding. Let's go ahead and submit it. I like it. We'll keep the smiley face in there. Let's see what other people did for solutions. Yeah, oof, see. Oh, they did the entire like ASCII table. Oh, return that. Yeah. Lambda, you can even do that, and then I don't even know like that. What is all that? See? So he hard coded all of the. Oh, and then he did all this other stuff. Oh, that's. Whew. I don't even know. It's not best practice. I think these people are being ironic. Alright, so let's do another one. Alright, because yeah, the idea is we're doing difficulties of the super easiest. So you should be able to do see, now we've got some greens showing up here. And we can even sort them for like, sort by stuff I haven't done. Wait, no. Oh, wait. Status, no. There we go, progress. So the ones I've done, the ones I haven't done, the ones I've tried. So I've got tried, done, and haven't. So that's really cool. Wait, why are they all blue? Because I'm filtering on Python. Okay. Sorry, answering my own questions. Like, how good are you really? Let's just take a look. That seems intriguing. There was a test in your class and you passed it. Congratulations, but you're an ambitious person. You want to know if you're better than the average student in your class. You received an array with your peers' test scores. Now calculate the average and compare your score. Return true if you're better, else false. Oh, this is awesome. Okay, so now we need to calculate the average. So already, I'm going to say, 4 grade in class points, because it's an array, so it has, you could search or iterate through each piece in it or each grade, and then let's actually do a variable up here. So whoops, running total equals 0, and then down here running total plus equals grade, and count plus equals 1. Count starts at 0, just to keep track. So we're going to do an average. So now, and we can even do it average equals 0. And then down here, after we've calculated all the variables, that's why we declare the variables up here before we do the stuff, and then we do this. So that's why we have that order. So averager equals running total divided, I think it's one or the other, so it's either an absolute value or average. It's either a single or double. Count if average less than, return true if you're better. Okay, so if average is less than or equal to, no, just less than your points. See, that's what we're being fed in, so we know whatever that is. Return true. Oh, wait. True. Yeah, I think it's just the Boolean. Else. Had to remember how to write an if-else. I haven't done that in a while. Let's see. Let's attempt that. Okay. I wasn't sure because I feel like there's like a corner case, or this needs to be a single. Let's see if it does a... Let's do this. Okay, doesn't matter. They're whole numbers. That's interesting. I don't know which is the difference. Like, we could change it with the test cases, but that's fine for now. Let's see. Wow, we're already at, like, we've done what, like 3? So 3 in about 10 minutes. That's about average for someone who's been doing them a long time. Now, imagine, you know, when you're just starting out, this is going to take you a little time. So, I mean, already you can do these for your account, but that's also why we're kind of just burning through a lot of these white ones. Mostly because it's easy, but also because, like, if you watch every single video, I want you to be able to know how to do this on your own. Like, that's how you really learn. Like, anyone can copy and just do, like, the exact thing. Like, and for a while there, you might even be like, you know, like, see, so even like right there, that didn't matter, spacing between these, like, it's not good, but it doesn't matter. Python is very forgiving. Actually, I guess Java is too, and it's forgiving and not. Like, it's good to keep your code clean like this. See, like, notice everything. I like to put a space between groupings of things. Like, I like to put all my variables right here that I'm going to use. So these are the pieces that I'm going to use to solve this puzzle. So I need a running total, I need a count, and I need an average. And try to name your variables something intuitive. Like, you might think of something different, like instead of count, you might do like num_vars, or which is like short for number of variables. Or a running total, you might say is sum, and then you get the sum, and then you divide by the number of, or the number of, or the count, or whatever you want to think of. Basically, and if you're not aware of the how to find the average of numbers, that is the equation. So if you don't know that, just like find average. How to calculate the average? You can just look it up. So the average of a set of numbers is simply the sum of the numbers divided by the total number of values in the set. And notice they already like highlight it for you. Like, Google is very smart. Like, you know, because it is built off of all the searches. I'm just kidding, not all the searches, but like a lot. Anyways, so that's just how to do that. So any of these challenges you should try to attempt. Like, oh yeah, so now I do want this thing to go. Oh wait, whoops. Back. Can I do that? Oh well, whatever. Let's just write it again, because we didn't attempt it or submit it. Oh wait, did we? Oh, we could also change. Let's do it. Let's do a Java. Just to show you, this is completely random, but this is the difference of coding in Java. So now you have to have curly brackets for the class, curly brackets for this is the method, which is the same as the function in Python, or the equivalent of a function in Python. But you have to do public, static, boolean. You got to tell what you're going to return. So now we know that it is a boolean, true or false. Whereas before with Python, let's see, and really you should do that and down. So actually, let's not do. So now that I think about it, because you got to go through each. That'd be like for I equals 0. Yeah, no, this is a whole bunch of stuff that's not going to make any sense to you. So anyways, let's just get out of here. So I think so we can check this way. We can go to our profile and see kata. How good are you really? We did it. Completed in Python. See, that answers my question. I couldn't remember if it counted it, or if we actually submitted it or not, or if I just jumped out of it. And these are all the ones we've done. We've done, did she say hello? Wait, really? I don't even remember this. I don't remember any of these. I just did those, like, what, the videos were from like a week ago, 2 weeks ago? Anyways, doesn't matter. I have done literally hundreds of these challenges, so it's hard for me to remember specific ones anyway. Like, literally hundreds of the white ones on my personal account, and then let's just do drink about. Let's just keep doing them. Anyways, kids drink toddy, teens drink Coke, young adults drink beer, adults drink whiskey. Make a function that receive age and return what they drink. So, this is good. So we have these conditions. Let's go ahead. So this is very similar to the example that I talked about. Whoops. Oh no. Python. Whew. Huh. Okay, good. I just want to make sure. So based on the age, and so we have these ones. So this is what a kid, so children are under 14 years old. So if age is less than or equal to, so it's under 14 years old. So if it's less than or equal to 14, return drink toddy. Now we can just take this and copy this. Control C, enter it. Control V, see it even lines it up, but we got to change this to an elif. So it's else if age is less than or equal to 17. We change this, double click to highlight it all, just the words. So double click highlights the word, triple click, or spazzing click, no, it's triple click highlights the whole line. So double click to get that. Alright, so drink Coke. Now, actually let's go ahead and copy this so we don't have to keep changing the elif. Beer, and whiskey. Okay, so now the condition of is if it's less than or equal to 18. So see, I could just be like if it's equal to 18, but since these already return, I don't have to worry about that. I can actually be sloppy about that and do, but we got to change it to beer, which I disagree with. I haven't drank alcohol in over 3 years, so, but that's just me. And whiskey. Not to say I haven't had plenty of beer, whiskey, and just about every alcohol. So, alright, now, so the only other condition, young adults under 21 years old. So you can tell this is in English as a native, which is fine. It's totally fine. Adults have 21 or more. Having is like tienes años in español. Yo tengo 35 años. I think that's I am 35 years old, but it's I have 35 years, so that's how many I have. Just like I call myself me llamo. Anyways, sorry. So for this one, it's 21. Actually, 20. Oh wait, no. Wait, 18 drink beer. Hold on, sorry, I got this confused. So toddy is fine, so anything under 14 is good. Anything 15 to 18. Oh, it's not inclusive. Okay. So I'm just looking at the examples. Wait, what? So this one's 20. This is just else. So I was going to say, at some point, adults is everyone or more. So I think this is right, and then this is irrelevant or unnecessary. Alright, let's try that. Drink beer should equal drink Coke. So I misspelled whiskey. Okay, so there's that. So that'll take care of those test cases. But I'm trying to think of, so drink beer should equal drink Coke. So we'll put the equals back in there. I think I was thinking about that. Alright, cool. Let's go back and look at the instructions to see. Teens under 18 years old. So 17 and under. Okay, I think I was even thinking about that because I was subtracting 1 and then making it less than or equal to. Okay, you could also do less than 18. And I think that's where I was getting confused. You could do either or. You could do less than or equal to 13, but then, so actually let's do that. Right, and then make sure we didn't break it. So now it's uniform. All of them are less than or equal to. Alright. Outstanding. Okay. And that's a good exercise to understand, like, the less than or equal to versus just the less than. Like here, if age is greater than 20. So yeah, 21 and up would be that. That's a good way. That's probably the best way. That's like code golf, like the least amount of characters. I like the if else, but I mean this is like, okay, this, that. Let's see. This is the one that's a little bit harder. So ours was a more scalable solution than this. This you have to explicitly say between this and this. Like this is a lot of extra typing to do. Even like, well, yeah. Whereas here they're doing it backwards. So they're doing, if it's like this, okay, everything like that. And we did it the other way. We did, if they're the youngest, do this, and then if they're this, do that. But since we were doing it, we were shaving off everything younger than this. So we were already saying between this and this. So yeah, that's why I like using the grade example, because it's like if you're greater than or equal to 90, it's an A. So that includes everything. If it was 1,900 whatever, you still get an A. Let's calm down there a little bit, by the way. So anyways, so that's good. We got that one. Let's just keep going. We got like 9 minutes. Let's try to make this closer to just like 30. Because this is what I intended, like a bunch of really easy ones. That first one we did last episode was just ridiculous. It took almost like, what, 20, 25 minutes to do it. And we didn't even do it. That's going to be our badge of shame. Anyways, fake binary. Alright, so given a string of digits, you should replace any digits below 5 with a 0 and any digit above 5 with a 1. Return this resulting string. I love it. So binary means it only has 1s and 0s. So, wait, what? Oh, expected. Okay, so now they're doing it backwards. This expected comes first and then the input comes second. That freaked me out. So, this one, very easily, we're going to build, whoops, return string equals empty string, and for char or digit in x, if int digit, I think that's how you cast it, because it's going to be a character, is less than 5. And then greater than or equal to is 1. Okay, so less than 5 is a 0. Return string plus equals a quotation 0, so it's a string. Else return string plus equals a 1. So if it's anything else, it's a 1. So that's like the quicker way, the better way to do it. Let's see. Let's see if that's correct though. Okay, none. 4-digit in is it just this? Yeah, no, because it's a string and an int. So wait, none. So I think this is right. Let's go ahead and oh, that's right. Return the return string. Okay. Sorry. Okay, that makes sense now because it had nothing for everything. It was like, what? It's not. Okay. So, and this is what's going on. So right now, I basically went like, okay, if it's less than 5, so it's 5. It could be -9, really, because it's really, although it can't because it doesn't have any negative numbers. Anyways, less than 5 is scalable, so if there were negative numbers, say these were actually a list of like several numbers, because if there was a negative, then this would break it, because then it would be checking the int cast version of a negative, a dash, because it would be treating everything as one character, every digit, because it really does character by character in a string. So we're being passed in a string, which is x, and this is x for the first one. And so we're going, okay, what's the 4? Less than 5. Let's add an actual string version. Or we could also do, this is kind of dumb, string 0. Because that's like hard coding that. I don't know. I feel like this is the same thing, but I feel like this looks cleaner because you're not. Why cast it when you could just write it as a a string? So, anyways, unless you're trolling or being clever or being silly, not trolling. Sorry, being clever, being silly. I think are really the only things. Like people might troll in the comments a little bit, but honestly, I feel like everybody's pretty good about online etiquette, and if they're not, they'll be taught pretty quick. So. Okay, so that was a good, easy one, and we're just going down the rows. Like, we've had a lot of really good ones. That's how whites are supposed to be. I would actually downvote that first one, but I don't care enough to do it. I unlocked a new privilege. Oh, you now have the ability to vote on Beta Kata. Nice, 25 plus honor. Okay, that's a very low-hanging fruit. Ugh. But I mean, no, I'm sorry, I shouldn't have said that. Like, your overall rank is now a 7 Caillou. So we've actually ranked up. Never mind. So that's how easy it is to get to the first step. So never mind. Sorry, I shouldn't say that. Like, that's not low-hanging fruit. I mean, it is. But if you're just starting out and you're just learning this stuff, then yeah, pat yourself on the back. Because this is, I mean, if you can get, what was that? 1, 2, 3, 4. Oh, actually, sorry. We could even see. Go back to our profile. Our solutions. I do kata. Then it's like the abbreviated. This is how we did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've done 10 challenges. That's interesting. I thought they'd be like, so like 3 a third? Wait. Yeah, 10 challenges. Sorry, right there. Interesting. Total completed kata. What? I don't get that. I think it's also because we've only done white. So, and then this is our actual rank. We're 7 Caillou now. So technically we should be doing the 7 Cailloux. However, we're going to keep doing the 8 Cailloux. Especially because we only have 3 minutes. So let's try to see is he going to survive? I don't know. A hero is on his way to the castle to complete his mission. However, he's been told that the castle is surrounded with a couple of powerful dragons. Each dragon takes 2 bullets to be defeated. Our hero has no idea how many bullets he should carry, assuming he's going to grab a specific given number of bullets and move forward to fight another specific given number of dragons. Will he survive? Okay. Oh, I think this is an easy one. Let's try to hurry. So wait, so each one, if bullets divided by 2, let's try to separate that out. Oops. Bullets divided by 2 is greater than dragons. Return true. Else turn false. Already I noticed I didn't do that. Need to do a colon there. Let's see. False should equal true. Let's try just one of these. False should equal true. Greater than or equal. There we go. Alright, see, that was a quick one. So we did that in like a minute. Basically, you need 2 bullets per dragon. So if there's 5 dragons, you need 10 bullets. If you need 4 dragons, you need 8 bullets. So you just take whatever bullets you have, you divide it by 2, and if that's, so. Or if dragons times 2 is greater than bullets, in fact, yeah, let's even show that. If dragons times 2 is greater than bullets, return false. Else, return true. I don't know if I need the equals. Yep, so we could do it either way. So if dragons times 2 is greater than bullets, or bullets divided by 2 is greater than dragons, but that doesn't make sense, you just like, oh, say you need, but you're trying to find out, oops, Control Z, I didn't mean to click and drag that. So you're basically just trying to find out if you have twice as many bullets as there are dragons. So you can double the amount of dragons to see if it's greater than your bullets, or you can do that. So anyways, that's 30 minutes right there. I will see you in the next one. Ta-ta.